Hello girls, and for this video, I'm going to go over notes from section 2.2, but before that, go to your comp book. So for example, in your comp book, and go ahead and however you want to do it, but one way is just to fold down one sheet so that then you can put on there, this is going to be a new section. So you can put like unit 2, most of it's going to be from chapter 2. So go ahead and do that so that you can tell where a new set of information unit starts. So for section 2.2, this will be the first section that we'll cover. And from this section, what we're going to focus on is graphs of lines, okay? So all of our equations will be for linear equations. So for example, go ahead and write this first example down. Go ahead and write down the equation y equals 2x plus 1. So we know it's linear because x is to the first degree and y is to the first degree. So what I want to have you do is determine if certain points are going to be on the line. So if certain points are going to be on the line. So for example, if you're given a list of points, so these are the points you're going to choose from. Okay, so we want to verify which of those points actually lie on the graph, okay? Or basically are solutions for the equation. So one way you can do it is you can substitute in. So you can substitute this in for x and this value in for y and see if it makes the equation true. So for example, if I use 1, 3, I'm going to put 1 in place of x and 3 in place of y. So 3 should equal 2 times 1, because that's what x is, and then plus 1. So 2 times 1 is 2, plus 1 is 3. So that does equal, does make that equation true. So 3 does equal 3. So that is going to be a point that lies on the graph. Another way you can do it is you can go to your graphing calculator. So you can go to your graphing calculator and I'll start from the beginning. So go ahead and go to the y equals key. So go to your y equals key. And if it's already solved for y, you can substitute that in. So go ahead and put in 2x. So remember, this is where the x key is, and then plus 1. Now, you can hit graph, and that's going to give you a picture of the line. But go ahead and go to the table. So hit second graph, because see how the word table is above there? And then you can arrow up or down. So for example, 1, 3 was on there. Let's go to see where x is 2. It says y should be 5. So this point, 2, 7, is not going to be a point on that line. Let's test out 4, 9. So if I arrow down to where x is 4, the y value is 9. So yes, that would be another point that's going to be on the line. So there's a couple different ways you can test that out. Let's do one more. Now, on this one, I'm going to have a solve for x first. So go ahead and write this down. Write down 2x minus 7y equals 14. Okay, so let's go ahead and put it in slope-intercept form. So let's do that. So start by solving for y. So I'm going to leave this alone, leave that alone, and subtract 2x from each side. Bring down the negative 7y, so put negative 7y equals, and remember, these are not like terms, so write them as two separate terms. Go ahead and put the x term first, so you have it in, and then plus 14, and then divide each term by negative 7 and simplify. So in slope-intercept form, we're going to have y equals, so this is going to simplify to a positive 2 over 7x, and then minus 2. So now, remember, that's in slope-intercept form. So here is our slope, and here is whatever is added or subtracted here. There is the y-intercept. So we would say the y-intercept is at negative 2. Okay, so let's test out and see if there's an ordered pair that's on there. So go ahead and write down, so we're using this equation, and go ahead and write down the ordered pair of 1, 6. Okay, so if we substitute in, y equals 6, so 6 equals 2 sevenths times 1 minus 2. So if we do the math there, 2 sevenths minus 2 is going to be a negative, so those are not going to be equal.